I'm going to borrow your calculator again. Number 30 says, assuming a current world population of 7 billion, annual growth rate of 1.8 per year, worst case scenario, exponential growth, world population be in 35 years. On your reference sheet, I want to write down, it's basically a PERT. No, but it's written down as A of, I think it's written like this with a KT or something on it. Basically, K is rates, T is time. This A naught is your initial, what you're starting with. Take what you start with, the 7 billion, E to the 0.018 T, and T happens to be 35 in this case. So, and my answers is in billions. I'm not going to put all them zeros on there. So, 7, E is second ln, and 0.018 times 35. It's growth, right? It's not decline, right? Population growth. If it was decline, that'd be a negative right there, but it's not. 13.14, 2 decimal places. Yeah, don't put all the zeros in. Just use 7. 7 billion. Billion. Everyone got 31? Does everyone know the quick way to do 31? It's that number right there. If it's a quadrupling time and it's timesing it by 4, then it's that bottom number right there. This is remember what we said this A naught was, it's the initial what you start with, and that's quadrupling time. So 3 over 3 gives you a quadrupling. 15,696 divided by what we started with, which was 981. That's 16. 16 times. So 16 equals 4 t to the third. You can rewrite this as 4 squared. So multiply by 3. 6. $32 is super duper easy. X equals 4.5. LNs and E's kill each other off. $33. Evaluate the following logarithmic expression without the use of calculator. I'll be dang. It's 1/6 to some power gives me 36. You can sit there forever and do it, right? But what is 1/6? Can you get rid of the 1/6 thing here? It's the same thing as a negative power. So 36 is 6 squared. So x is -2. What do you mean, multiplying? X equals -2. Negative x equals 2. And remember, you can check your work. You're not supposed to do it, but you can check it. Log 36 divided by log 1/6. You get -2. But if it says without the calculator, you got to show your work. 34. Could you rewrite 81 as a power as base 3 with a base of 3? 3 to some power? What could you rewrite 81 as? To the 4th? Okay, so that means that the 3's would basically cancel, and you can set this equal to 4. Four to the 4th power equals x. And I don't know, what is 4 to the 4? 256 or something like that? 250, 256. If I want to punch these things all together, it says to condense it down. The 5 becomes a power. The negative 9 becomes a power. And what I wind up with is ln 10 plus ln x to the 5th plus ln y to the 9th. And if we're adding them, we're multiplying everything. So it would be natural log of 10 x to the 5th y to the negative 9th. But what happens with negative exponents? They drop down. So you got ln of just that one dude. On 36, you're going to use your change of base formula. Log 575 divided by log 11. And it works with ln's as well. You just punch it in the calculator, log 575, just like I did this one. .65. And this dude is exactly like this one, just in reverse. Number 37 is exactly like 35 in reverse. So 4 ln plus 8 ln x minus 3 ln y. Powers would come out to the front. If it's on the bottom, you subtract. If it's multiplied together, you add. I skipped a whole bunch of steps here, but I'm trying to hurry up and get through all this. But if you can do this forward, you can do it backwards, right? You should wind up with that right there. I'm gonna split apart the 4 and the x to the 8 with a plus. The power comes to the front. Since it's on the bottom, we subtract, and you pull the 3 out to the front. You want to go ahead and do the rest of them, or you don't want to have any specific questions besides 38, 39, 40, 41? What would you do on 38 here? What's that? Yeah, do an ln on both sides because it kills off the e. So you get x minus 7. Ah, crepes. Piece of paper. Bless you. And then this right here comes down to the front. Property of natural logs, so that can come to the front. This is all one number. This is just like saying 3x. This whole thing. This is a number, and you're timesing it by this. This is just like saying 3x. If it was x minus 7 equaled 3x, what would you do? You'd move the x over, wouldn't you? So that's what I'm going to do. So I'm going to subtract this over and move the 7, I'm going to smooth that over. I guess this is ridiculous to do it this way. And I'm going to move the 7 to the other side. X is on one side, numbers on the other. Now I'm going to factor out an x. So I don't have any more x's mixed up with this. And now this right here is just a number. It's being multiplied by x, so if you're doing that, you can divide it out. That's what your x value is. And we need to write it, we need to figure out what it is. So we need to punch that in the calculator. And parenthesis. $10.64. What you got? Well, that's fine. You didn't get 10. You didn't get 10.64.
Yeah, but I didn't get the 7. Does that matter?
You didn't get the 7.
The 7 over 1 minus 2 is 10.
Well, what'd you get?
Negative 105 over 2 ln 13 minus 16. I multiplied this by 16.
Oh, that's fine. Yeah, it's fine. That's fine. As long as we're getting the same.
That's the same thing.
This is the exact expression, and this is the decimal approximation. If we get the same decimal approximation, then we got the same exact thing. So if you'd multiplied out the 15 to begin with to get rid of it, yeah. There's a lot of different ways to do these. A lot of different ways to do them.